What's happening, guys? Aruj again, and this time we're talking about population ecology. So let's first talk about what could limit a population. What limits the growth? Why don't species reproduce into infinite numbers, okay? First, let's go over some basic vocabulary. First, we have the carrying capacity. The carrying capacity is the maximum population that an ecosystem can support, the maximum number of individuals that can live within an ecosystem. Next, we have limiting factors. A limiting factor is any biotic or abiotic factor that can restrict or lessen the number or reproduction of a population. So what limiting factors do is they limit the number or the individuals in the population, okay? Limiting factors can be biotic or abiotic. Now there's two types of limiting factors that I want to cover. The first type is density dependent factors. Okay, break that word down. Density dependent means that this is caused or dependent on the density, how close those individuals are with each other, okay? They are caused directly by the population. So take a look at these examples of limiting factors. Food, predators, shelter, mates, disease, fires, weather, volcanoes, floods. Which of those would be caused by the population? Would the number of individuals cause a volcano to happen? No. Would the number in the population cause fires to happen? No. So density dependent factors are caused by the population, and what they are examples of are like food. You can run out of food. The population could eat up all the food in the environment. That would cause the population to dwindle. It could be the number of predators. It could be shelter. That's dependent on the population. If there's too many individuals that take up shelter, there's not enough for the others, okay? On the other hand, we have density independent factors. Those are not caused by the population. For example, a volcano eruption, that's not caused by the population, but it can limit it. So that's density independent. It's not caused by the population, okay? Now we have two patterns of growth. We have exponential growth, and that is the rate of growth. And as it grows, it becomes more and more and more rapid. When we see this, it means that the population is unchecked by limiting factors. You guys will see an example of that in just a moment. And next we have logistic growth. In logistic growth, the growth rate stabilizes. It shows that the population is checked by a limiting factor. There is something that's preventing the population from growing out of control, okay? Go ahead and take note of this slide, please. And let's go over population size. What are four basic things that affect a population size? Well, simply put, we have immigration. Immigration is when new individuals enter the population. And we have birth rates. Birth rates is the number of individuals that are born into the population. On the other end of the spectrum, we have emigration. That's when individuals leave the population. And we have the death rate. The death rate, simply put, how fast the individuals die from the population. So what ecologists do is they just go ahead and assume that immigration and emigration cancel out. So really they don't study that too often. What they really focus on is what is causing birth rates and death rates in the population, okay? And what's going to affect the birth rate and the death rate are going to be those limiting factors, okay? So an example of those four factors would be this. Let's say we have a population of squirrels. Let's say one has 3 children. One dies off. We get another one that enters the population, and we have 2 that leave the population. Those 4 things would affect the number of individuals in that population. And now let's take a look at this. Let's say we have a population of rabbits, and rabbits reproduce really, really fast, okay? So 2 becomes 4, 4 becomes 8, so on and so forth. And why don't we see the world overrun by rabbits? Why not? Well, the answer is the limiting factors, okay? If there weren't limiting factors, we would say that there's exponential growth. As the rate increases, or as the numbers increase, so does the rate increase, okay? And it would look like a J curve. That's what the graph would look like. What the J curve tells us is that the population is unchecked. There's not something that's going to drop that number of individuals, okay? We really don't see exponential growth. There's always going to be something to check the population. So really, population growth looks more like this. It looks more like logistic growth, which has an S curve. And the population starts to increase exponentially, but then it starts to level out, okay? It starts to plateau. In reality, what this line will look like is it'll fluctuate. It'll go above and below the carrying capacity, but it'll hover around that area, okay? And this maximum number that it's fluctuating around, this is the carrying capacity, okay? So logistic growth is when limiting factors keep the population checked. It doesn't allow it to continually grow out of hand, okay? That is it for today, folks, and I'll catch y'all next time. Peace.